I want to talk about one more thing to watch out for, and it comes up in the last problem we worked on, so I've copied the work on that problem over to this fresh sheet. The issue is that there's an extra domain restriction that maybe wasn't obvious at first, and I want to explain where it comes from. In this particular problem, it's a division problem, and it starts with this fraction divided by this fraction. Okay? Remember, with fractions, denominators cannot be equal to 0. The first denominator is going to remain in the denominator. The second denominator, though, of x squared minus 16 is not going to stay there. When we flip and multiply, that denominator is going to end up being in the numerator after the flip. So even though that denominator of x squared minus 16 can't be 0, technically, it doesn't show up in the denominator anymore. So anyone reading this answer at the very end wouldn't realize that, in fact, this x plus 4 right here that shows up in the answer came from a denominator. So what this means is that when we work through division problems, and again, this only happens in division problems, we need to make sure that we keep in mind that whatever we had as our second denominator, and it's only going to happen with the second denominator, the one that you flip that goes into the numerator, we have to consider all of the things that would make that denominator 0. Now, because we're factoring as part of the process, we can see that x equals 4, and here, right here, x equals negative 4 would have made that 0. So we already talked about how we don't have to worry about writing down x equals 4 because we have a x minus 4 in our final answer in our denominator. But we do need to say that x cannot be equal to negative 4 because that's not clear from the final answer. You can't tell that from the final answer. We can only tell that from coming back to where we started originally, that both of those denominators can't be 0 right from the get-go. So this is an extra domain restriction that comes from the fact that x squared minus 16 was originally in the denominator, and all denominators cannot be 0. That is a thing that we need to always pay attention to with these types of problems. So extra domain restrictions can come up in division problems. Let's look at one more example to kind of clarify that. So here's one more example where we have a rational expression dividing another rational expression. I have gone ahead and factored it and set the problem up so we don't have to worry about the factoring process. What I really want to consider is what our final answer and what our domain restrictions would be. So first off, what we would do is that this is a division problem, so we're going to flip and multiply. So rewriting this problem, we would have the first fraction as is, 6 times x plus 5, all over x plus 2 times x plus 3, and we'd multiply that by the flip of the second fraction. So now x plus 3 is going to be in my numerator, along with x plus 4, and then in the denominator I'm going to have x plus 5. Once we make it into a multiplication problem, we can go ahead and cancel common factors from numerator to denominator. So I've got an x plus 5 in the numerator and an x plus 5 in the denominator, so those cancel. I have an x plus 3 in this denominator, and that cancels with the x plus 3 in the second numerator. And what I'm left with is 6 in the numerator multiplied going across to x plus 4 in parentheses. And in the denominator, I'm only left with one factor of x plus 2. I can either put the parentheses in or not. It's your choice. It's the domain restrictions that I really want to pay attention to here, and that's what I was mentioning before. Now, the domain restrictions come from what we've canceled out, because what we want to show someone who's reading the final answer is that these cancellations only occur because they came from factors that were not equal to 0. So in my x plus 5, that would be 0 if x was negative 5, so we say x cannot be negative 5. And then x cannot be negative 3. That's from that other cancellation. And then there is one more thing we have to consider, And that last thing comes from the fact that we originally had as a denominator x plus 3 and x plus 4. Because we flipped and multiplied, that x plus 4 and the x plus 3 end up in the numerator. I didn't cancel the x plus 4, so it ends up in the numerator. So for a reader just looking at the problem at the end, they wouldn't realize that I technically can't have x equal to a negative 4. Again, that's because that started in the denominator. So my last restriction is that x cannot be equal to negative 4. Again, because it was originally from a factor that was in the denominator. So things you have to watch out for when you're dividing rational expressions in terms of domain restrictions. First off, anything where you've done any cancelization. And then anything where the original denominator could have been 0.